Hello and welcome to the programming procedure video for the Scale, Speed, and Robots activity by MyBot. First thing you need to do is go to your MyBot interface and then launch Blockly. For information on how to do that, refer to your MyBot Basics document. Once you're in a new scene, click Save to name your file. Name it your name _ scale speed _ V01 and click OK. Now in this program, we are going to tell a robot to travel in a rectangle, but we're going to make it so that it is highly adaptable and uses variables to control all of its different functions. That way, if you want to adjust your program at any point, you can do so easily simply by adjusting your variables. As always, this is just one way to create a code that will do this. Let's get started. Since we're going to be using variables, let's start with the Variables menu. Then, Create Variable. For this first one, type in power since it will control the power or speed of our robot, and click OK. When you do that, you'll notice you have some new options available to you now in the Variables menu. Options to set, change, or insert the variable you've created. Now it's important to set your variables before you use them, so let's bring this into our scene by clicking on it and dragging, and then dropping it onto the Fusion Start block. You'll notice it sort of pops into place. Now we want to set this to a value, so we're going to use the Math menu and grab the top option to select a value, which is simply a number. Bring it onto the end of your Set Power To command and type in 20. Now we're going to set up another variable for when we're turning. So, variables, create variable, in this case, turn power, and click OK. Now you notice when I do that, it doesn't give me an option for set turn power to. So grab your set power command and bring it below your existing set power command. So we need to change this to set our turn power variable. Use a drop-down menu and find the variable you want to set. Then repeat the process to set it to the variable that you found in your tests will have your robot turn 90 degrees in 1 second. Since we want to create this to be very adaptable, I'm also going to set up a variable for turn time. And I'm going to set that one to 1 second. And you can make good use of your copy and paste keyboard shortcuts to create these variables more efficiently. We're going to repeat this process to create 2 more variables. The variables will be original length and original width, which we can use to set up the dimensions of our starting rectangle. For these values, set them based on your specific rectangle that you've been assigned. And then set up a variable for scale factor and set it to 1 for now. You'll run 3 tests with this code when it's all done, where your scale factor is 1, and then 2, and then 3, to see how adjusting a single variable can adjust your robot's behavior. Now we're going to continue setting up our variables. These new variables will set the length or the time of travel based on the size of the rectangle. To do this, we're going to need 3 new variables. The first one is 1 block time, or the amount of seconds it takes for your robot to travel 1 block. I'm going to put that right up here at the top and insert a value according to my tests. The other 2 variables I'm going to set up are length time and width time. For simplicity in reading my code, I'm going to set these right below the original length and original width variables that I set up already. For both length time and width time, these are going to rely on variables we've already set up, and we're going to need to create an equation to tell the robot to travel 1 block time per every block our robot will travel on our rectangle. So to do that, go back into Math, but instead of grabbing a value, grab an equation. That's the second option down, and bring it both onto length time and width time. Now by default, it starts out as an addition equation, but since we want to multiply the length of our rectangle times the amount of time it takes to travel each one of those blocks, we need to change this to a multiplication equation. Use the drop-down menu and select the x. Do this for both of your equations. Then go back into variables, and this time we're going to use these insert variable options that have been created each time we've created a new variable. So for the first half of our equation, we're going to use our one block time variable and multiply that times the length or width of our rectangle. And then we're ready to set up our final variable. That is our scaled power variable. And this will allow us to control the speed of the robot based on the scale factor of the rectangle. And we're going to set this up similar to how we did length time and width time. So create the variable, set up the equation, and use existing variables to fulfill it. Great job! We've now set up all of the variables we're going to use in this program. But just to make sure we're doing everything right and we have the equations working the way we want to, let's add one text command. So in the text menu, grab the print command and bring it onto the bottom of your equation, and then tell it to print that scaled power variable. Feel free to add additional print commands for additional troubleshooting. Now we're ready to set up the behavior portion of our code. Since our robot's going to be driving, let's start with the motors menu. Use a simple drive at speed command, and instead of setting it to a designated power, let's use our variables. In this case, the scaled power variable. Click on it, drag it in, and attach it to the end of your drive at speed command. And then we need to tell it how long we want it to drive. So that's in the time menu, and you're going to use a wait command here. As before, we're going to not fill in a designated number of seconds, but instead use our preset up variables to find the variable that makes the most sense for our program. Now keep in mind, depending on your specific rectangle and route, you might be traveling down the length of your rectangle first or the width. So make sure you grab the appropriate variable for that. And then we need to tell the robot to turn. So grab a rotate left at speed command and adjust whether your robot needs to turn left or right using the drop-down menu, and fill in the two values at the end once more using the variables we've set up. Now that you have your robot going down either the length or the width of your rectangle and turning 90 degrees, we need to set this up one more time for the second side of our rectangle. Since we're doing this with a rectangle, we know that we can actually just repeat these 6 behavior commands 2 times so that our robot will travel down all 4 sides of our rectangle. To find a repeat command, use the loops menu and grab the second one from the top. Click on it and bring it just below any of the print commands you added. Change the value in the box to 2 times, and then drag your behavior commands inside your loop. Great job! You have now created a program that is ready to go and will tell your robot to drive in a rectangle at a speed that is controlled by the scale factor. So, click play and see what it does, and then change the scale factor from 1 to 2 and finally 3 to see how this impacts the behavior of your robot.